Today we're going to be looking at Leetcode 53, maximum subarray. We're told this is a medium difficulty problem, and we're told that we're given an integer array nums, and we need to find the subarray with the largest sum and return its sum. So here we've got an example, and the largest subarray is 4, minus 1, 2, and 1, because the sum of this equals 6. In this example, we've only got one element, so the subarray 1 has the largest sum of 1, and in this case, the entire list has a total of 23. So that would be what we return basically. So the sum of the largest subarray is the list itself, and we're given some constraints. So the most obvious solution is kind of a brute force approach, and that's using multiple for loops just nested within each other. So a first for loop to loop through all of the numbers in the list, another for loop to list through the numbers again, and then a third for loop to calculate the sum in between I and j. Let's say I being the first, the indexes for the first element for the first for loop, and j for the second for loop. And in that way we basically calculate all permutations, and then after we find all the permutations, we'd find the biggest one, and then return the biggest permutation. But that would not be the most efficient solution. It'd be quite inefficient, and it would also not have it would not be solved in linear time. It would just be a quadratic time level of complexity to solve the solution using a brute force method. So a better approach is called Cardan's algorithm, and it took me a while to wrap my head around it, but in essence, when we're calculating a sum, the current rolling sum, if it ever gets to less than 0, we start fresh from the next element. And I think it would make sense if we code it up in Python. So let's jump straight into the code. We'll set our max sum to the first element of our list. So in this case, for example, it'd be -2, and then we'll set our current sum, so our current rolling sum. Well, we'll set this first to 0, and we'll say for I in range of length of our nums, so we'll just iterate through our list. What we're going to say is if our current sum is less than 0, well then we can just set current sum to 0, because we want to start fresh now, because all the other elements, since they're negative, they're dragging down our total sum. And then we set current sum will be equal to we'll increment it by nums of I. So in this example, -2 plus 1 would be -1. On the next loop, -1 is still less than 0, so we'd start fresh from 1 plus -3 being -2. Well, we'll start fresh from -3 plus 4. Well, that's 1. 1 is greater than 0. So and we basically keep going, so on and so forth, and this would finally be the biggest perm that we can get. And of course, while we're doing this, we also want to make sure that if at any point our current sum is greater than our maximum sum, well then we can just use the max function in Python to figure out if our current sum or maximum is greater. So let's put in our current sum, and let's also put in our maximum sum. So if at any point our current sum is greater than our maximum sum, we'll change our maximum sum to our current sum, and we will return maximum sum. So let's run the code. And we pass all 3 test cases. Let's submit our code now, make sure everything works. Yep, we passed all 210 test cases. So in terms of time complexity, because it's just a single pass, it would be the time complexity of big O of n. So I hope this video made sense, guys. I hope my explanation of Cardan's algorithm made sense. It is a bit of a confusing algorithm. I think this question was actually ranked easy, but now it's medium because I think a lot of people did find it quite difficult to solve. But once you wrap your head around it, it does make more sense in general. So I hope you guys enjoyed this video, and I'll catch you in the next one.